vocab today, guys, and I actually have updated the Quizlet that I put on Edmodo that you can go and kind of review the vocab. But these are, I think, really important vocab words that maybe you don't know, like some of the other stuff. Like this word, adjacent angles. Have you ever heard that word before? Adjacent?
Yeah.
What does adjacent mean?
It means like right to the side.
Yeah, like next to. I could say Eric is adjacent to Mackenzie. Right next to. In a triangle, we have the adjacent side. We say that it's like right next to it. So adjacent angles are two angles that lie in the same plane. They have a common vertex and a common side, but they have no interior points. I think a nice way to think of adjacent angles are angles that share a side right next to each other, right? So these are adjacent angles. They share this side right here. This is angle 1, separate from angle 2, but they do share the same side. This one is an obtuse. Oh, actually, it's just a really weird angle. It's like bigger than 180. Would you agree with that statement?
Yeah.
But still an angle. That this is angle 1 right here, and then this is angle 2 right here. That they do share that one side right there, right? Adjacent angles. And then they give you, in your book, they give you non-examples. I'm kind of not a fan of non-examples because I feel like people will get those confused. But these are examples of things that aren't adjacent. Because you might, could you get a pair of adjacent angles out of this picture?
Yeah.
Yeah, just not the ones they labeled. This angle, they say, is not adjacent to that whole angle, right? Because angle 3 is included inside that whole angle. See what that's saying? No. Angle 3 and angle ABC are not adjacent because they have common interior points. Like it can't lie inside the angle. Do you see how that's different than the two angles over there? If this said angle 3 and angle 4, are those adjacent angles now? You see what I'm saying? Like they're saying the whole angle is not adjacent to the little angle inside of it. So just be real careful on the wording there. I'm not going to focus a lot on the non-examples because I'm not a fan of non-examples. A linear pair. My definition and the book definition might be a little different sometimes. The book says a linear pair is a pair of adjacent angles, so they share a side, with non-common sides that have opposite rays. I think a linear pair is a pair of angles that make a straight line together. Does that make sense? So you see how angle 1 and angle 2, they're opposite rays. They together would make 180 degrees. You see that statement? So a linear pair makes a straight line. And I'm going to put in parentheses 180 degrees. So then notice the non-example that does not make 180 degrees. That's why it's not a linear pair. Vertical angles are defined as non-adjacent angles, so they're not right next to each other, formed by intersecting lines. So if they're not next to each other, I think of them as across from each other, right? So vertical angles, angle 1 is adjacent to 3 and 4, so its vertical angle is angle 2, right? So I think of it as vertical angles are like right across from each other, which means angle 3 and angle 4 are also a pair of vertical angles. So if you have two intersecting lines, if it's not an adjacent angle, then it's a vertical angle. This is not a vertical angle because these, like, that's two separate line segments going through there. So that's why it's not a vertical angle. I don't like that. I'll not put it anymore. I just copy and pasted this straight from your book. Like, this is the exact picture from your book. So that's why the non-examples are there, but I'll take them out next time. So, linear pair makes a straight line. Vertical angles right across from each other in terms of intersecting lines. Those are really, really important words that are going to come up over and over again in this class. So make sure that you kind of learn them. Ooh, look at this lovely thing. It says roadways. I name an angle pair that satisfies the condition two angles that form a linear pair. And notice they have all those letters there, so we can actually label them with the three letters with the vertex in the center. So a linear pair are two angles that together are going to make a straight line or add up to 180 degrees. What do you think, Zoe? U I what? What did you say? UIP. I think. What do you think? Do you think that's a linear pair? UIP would be this angle, right? RIS would be this angle. That's not a linear pair, but what did you just give me? Those are vertical angles because they're right across from each other. You see that? So I think you just answered B. Name an angle pair that satisfies the conditions of two acute vertical angles. You could say angle, and remember that when you label an angle, the vertex has to go in the middle. So UIP and angle RIS. That's not the only pair, but that works. Yes, PIU and SIR are exactly the same. Right, the I just has to be in the middle. So if we stick with her answer here, anybody find an angle there that would be a linear pair to UIP? PIQ. What do you think? Does that make a straight line? No. What do you think, Chandler? QIR would be over here.
Yeah.
Does this angle and this angle? You guys are all around it here. Garrett, what do you think? That's an S down there.
Yes.
SIT and SR.
Yeah.
Sit, sir.
I think that works. Or it could be SIR. Those are the only two options. No, I think
We already tried SR.
What if I said UIP and PIR?
Thinking outside the bun.
I had fun with that.
I don't. You guys are picking just all these little angles, right? Like you felt like you. But isn't this an angle? PIR? Do you see if I go from this angle all the way over to the other angle that I picked, does that make 180 degrees? Does that make a straight line? That's a linear pair. When they make opposite, they have to make opposite rays, right? Let's go back to that definition. They're opposite rays, which means they have to go in opposite directions, right? The side they don't share has to go in opposite directions. That's how I know it makes a straight line. So this is opposite of this. What do you think?
Yeah. Well, are they usually going to be two different, like, okay, for example, you're using colors, like you have red and blue. Are they usually going to be two different, I don't know how to say it.
Like they shouldn't share side, you mean? Like, what do you mean? I don't know what you're saying.
I don't know how to explain what I'm saying.
Let's pick another one. I'm gonna pick an angle, and you're gonna tell me it's vertical angle. I mean, it's linear pair. All right. The key idea is you need to find an angle that would have an opposite direction, right? So if I picked PIQ, I need you to pick another angle that will have an opposite ray, and there's actually two different angles here that could be a linear pair with this. For that, Mackenzie, what do you think?
I think QIR or QIS, my bad. Because it goes opposite ways and it shares a line.
UIS, QIS. Sorry, I was doing UIS. I think that's right. Because if you measured those two together, they make a straight line here. Share that side in the middle, opposite rays.
You just UIS. Why did you say GIS?
P-I-S. No, but you could say P-I-T. What would be the measurement of P-I-S? Yeah, like that's the whole thing, right? You see what I'm saying? Like that would be counting this angle already. You see what I'm saying? Whew, okay. What?
UIS work too.
No, because that would be too big, right? You see what I'm saying? Like, that would be opposite right here, but when you added that up, I don't think it would work. All right, let's try this. It's gonna go everywhere. All right.
Dude, hold on, hold on.
This is the Chromebook thing, all right? This is not on your paper. I'm going to save some paper here. This is only up here, okay?
Safe.
Go open your Chromebook to Socrative. It says A, B, C, D, and E. Please don't pick E. There's no E. Name two adjacent angles whose sum is less than 90, and only one of those is true, okay? So look at those angles. Think about where they are over there. Two adjacent angles, that's the key word, whose sum is less than 90. Alright, I got my answer too. So click your A, B, C, or D, and then we'll see from there what we said. Oh, sorry. Yeah, are you ready to take it right now? Do you want me to pull it up for you, or do you want to do it? Mackenzie, go in there and click that bottom thing where it says the Google Chrome button at the very bottom of that toolbar. You see it?
Yeah.
B is the right answer. Alright, Mackenzie, go back and click the smart board or just click Chromebook again so it'll close. Now click the arrow at the top that will take you to the next screen. There you go. There's another one, but oh wait, hold on. Go back to Chrome. You got more work for me.
It finishes. Wait.
Hit another question at the bottom where it says multiple choice. Hit that. Okay, now hit Chrome. Here, yeah. Thank you. Name two acute vertical angles. That's funny. Make sure they're acute and vertical. Because I almost just said the wrong one. Alright, I got my answer.
I think I have.
Yeah, vocabulary is really important on a test. If you don't know what vertical angles are, you don't know what to pick. If you ask me during a test what's a vertical angle, I'm going to say I can't tell you.
No.
I'm going to show you later. Does it? Or like when you submit it,
You're ashamed
You
of
get
what?
picky, and then I would just make them.
I almost couldn't see it. 'Cause I thought it was.
If you look at one of those angles that is not acute, you should be able to throw it out right away, right? But then the other part is vertical. Remember, vertical are non-adjacent angles. I think of them as angles that are like across from each other in intersecting lines.
Well, the one that I would have up there is not up there.
But there is a right answer up there,
Oh, darn.
right? Like,
I
let me just.
chose the wrong one. Okay. I picked ones that weren't. I'm pretty sure.
These are acute. These are vertical angles.
They're not.
BAN and DAE or EAD. Those are vertical angles, but they're not acute, so it doesn't. So A is not the right answer.
I messed up on Latasha.
These two are vertical angles. These two are vertical angles, but you just have to figure out which one's up there. BAD, well, BAD is this whole thing, and BAN is not even a vertical angle to that. I think it's got to be D. Did you pick D?
I picked.
You're picking it now.
I did now.
Doesn't help if I try to answer. Why is it D? FAN. So that's this angle. And DAC is this angle. And yes, it would be easier if you had that in front of you instead of up here. But I hate wasting so much space.
So, does it add up to plus 50 angle, or does it?
Each one's acute.
That's what I was trying to do. I was trying to add it up.
Okay. I'm not even gonna look because I told you the answer. All right, here we go.
Are we done with the drum?
I think I have one more, but you can try to pronounce. You're gonna just go back and forth. You just have to get used to this.
Okay.
Why are vertical angles so important? Because vertical angles are congruent. So if you know two angles are vertical, you know they're equal to each other, which is really important in terms of solving things. So if you have two intersecting lines, you know the angles across from each other are always the same measure. Do I have something else here? No, just kidding. Okay.
I feel like I can get what I put up there.
These words I think you know, right? Complementary angles, supplementary angles. You heard of those before? You just got to remember which is which. Complementary angles are two angles that when you add them together, they make a right angle. So they add up to 90 degrees. And so again, there's some pictures there. It could just be adjacent angles that add up to 90 degrees. It could also just be two separate angles, but if they add up to 90 degrees, they are complementary. And then we also have supplementary angles, and those are two angles that add up to 180 degrees. And again, they could be adjacent, like 3 and 4 here, that add up to 180 degrees, or they could be separate that add up to 180 degrees. How did I always remember which was which when I first learned them? Alphabetical order. C comes before S, so 90 comes before 180. That's how I always remembered. So if you don't know that, that's a good way to remember. So I've kind of already said this, but if you have a linear pair makes a straight line. So a linear pair will always add up to 180 degrees. So if you have a line with two angles in it, you know they are supplementary. You know that they are a linear pair because they add up to 180. Questions about that? That's it for this slide. We're doing it all, buddy. How about this? And again, the words here are so important. One, there's algebra thrown in here, but you gotta know the vocabulary. Find the measure of two supplementary angles if the measure of one angle is 6 less than 5 times the measure of the other angle. You've done questions like the end part over and over again. The new part is the geometry part. If I say two supplementary angles, what do you know about these two angles? They add up to 180. So you could say, I don't know what you want to call them here, but something angle plus some angle, right, has to equal 180. We want to use some variables there maybe, I don't know. Angle X plus angle Y or something. Angle A plus angle B. one angle is 6 less than 5 times the other angle. Again, you can use whatever variable you want here, but if I call the first angle angle x, then I could write the second angle in terms of angle x, because they tell me that one angle is 6 less than 5 times the measure of the other. How do you write 6 less than 5 times the measure of an angle? What do you think, Zoe? Do you agree with that? And I would probably drop my angle signs over here. I would just change it to x's. Remember that 6 less than means minus 6 at the end. So I could say the first angle I'm just going to call x. And now the second angle I'm going to call 5x minus 6. But really important that you know supplementary means you set it equal to 180.
Can you do this with complementary too?
Yeah, it would just be 90, right? And so now we're just going to solve that. So I'm going to go ahead and add 6 over at the same time if you're okay with that. Divide by 6, and we get what? 31?
Sure.
Let's go with that.
Yeah.
Impressive.
Yeah.
Why is that impressive? 6 divides into 18 3 times, and 6 divides into 6
I had
one
to
time.
think about that. Okay.
It went nicely.
Well, you also convinced for longer
I
than
know. Well, like, it's really nice when it's broken up. Like, that's why I just broke it up into 18 and 6. Right?
My brain don't work like that.
Did we solve this question?
No.
Be careful, right? Find the measure of the two angles. So we just found one angle, though. We call the first angle angle x. So one angle is 31 degrees. How can we find the second angle? Yeah, it's supplementary. We could plug it in up here, but we could also just subtract from 180. You should get the same answer whichever way you do it. We call them x and y. You don't even have to do that in your answer, but since I did, I'm going to say that. What'd you get? And you could check the... All right, I think I got another Socrative thing. Let's see. What can I do? It's just a lunch number, right? All right, so just like what we just did, only I said find the measure of two complementary angles if one is 6 degrees less than the other. You should be able to cancel out two options very quickly based on the fact that it says two complementary angles, right?
Yeah.
See what I'm saying about that? Those choices are not all complementary angles. But I'll give you a second to try to work it out.
Can we work it out on our...
Oh yeah, definitely you can work it out on your paper. That's what I figured that maybe you would squish it in somewhere. There's a lot of info in today's notes, but it's not terrible. Like perpendicular stuff, vertical angles, that's kind of important. Linear pair, but I really don't think the homework is that bad. As we do this, one angle is 6 degrees less than 5 times the other.
Oh, I like this one. I actually do that.
Are we about there? And it's okay if we don't all answer, just so that we can get moving on here. But I'm gonna look, right? Oh man, we're 50% said C, but we got D as a close second right now.
Who chose?
I said B.
Oh man, now it's tied. Only 7 people have answered.
Yeah. Apparently,
if I call the first one X, the second one is 6 degrees less than 5 times equals 90. So 6x equals 96. Yes? So x equals 16.
So then you can
So it has to be C.
see what I did is I
let's
just
see
subtracted.
what I did.
I just subtracted. Oh, never mind. I got it wrong. That's fine.
So A and B I threw out right away because they didn't add up to 90. So you're at least down to 50-50 guess, which then someone picked D, but you know, whatever.
See what I did? I just subtracted 6.
So it's a 33, 30% Everybody 30-30, okay.
Close it.
It was C, right? Oh, close it, yes. I think we're actually officially done if you want to sign out.
Ah.
Are you sure?
No, but we can just sign out.
Okay.
Even
We're
if we get,
done with this, but go ahead and sign
if we
out.
get to another one, we'll just skip it. But yes, I'm almost done.
Sign down.
And I'll put it up later if we don't have time.
Shut
All right. There's also a bunch of stuff about perpendicular lines, and so I kind of put boxes here for you to fill in. Perpendicular, I know you've heard of that before, form two lines that intersect to form a right angle. Right, and that's the definition really. Perpendicular lines intersect to form four right angles. We could prove that really quickly based on what we learned today. Vertical angles. So if this is 90 degrees, do you agree this has to be 90 degrees? Linear pair, does this angle and this angle make a linear pair? So if this is 90 degrees and together it adds up to 180, this has to be 90 degrees, right? So we can prove why that works. I just feel like there's like more hidden stuff there. Perpendicular lines intersect to form adjacent angles because they're right next to each other. The third little bullet there just says that you can have a segment or a ray that's perpendicular to a line or a segment or a ray. They don't all have to be lines. We say perpendicular lines, but you can cut any line into a segment or a ray. That's all that's saying. And the right angle symbol in the figure indicates that the lines are perpendicular. And I think you've used that, especially if you did Pythagorean theorem. You've seen that little box before, right? That means perpendicular. So that's the official symbol on a picture for perpendicular. When you write it out, there's an official symbol for that too. So it's an upside down T. You see that? Have you ever seen that before? So when you want to say that a line is perpendicular to another line, you can write it in symbols like that. So that upside down T is the symbol for perpendicular too. Because it's mixed right angle, right? Yeah. So again, you know that word, and so now they can just give you questions, and you can use the fact that you know about adjacent angles and vertical angles and linear pairs, complementary, supplementary, and perpendicular lines to find some missing angles. So let's look at this example here. This lovely picture. It says, find x and y so that line KO and line HM are perpendicular. Ugh. And we could do a lot of stuff here. Actually, got to do a couple things here. What about y? Does anybody know an equation I could set up to figure out what y would have to be to make sure that, just make sure you know what line you're talking about. We want to show that this line, KO, is perpendicular to HM. So what do you have to know about this angle right here? This has to equal 90 degrees if we want those to be perpendicular. Right? It's not, you just have to think through of what could I set that equal to. Well, if those are perpendicular, then I can say 3y plus 6 has to equal 90. Again, not a hard equation to solve, but you got to understand what you're looking for to set that up. And I'm not even solve that yet. I'm going to also set up one for x's. Well, actually, let's just solve it, because maybe you'll think of something different. So if I subtract 6, what is that, 84? Divide by 3, that's 26. Is that true? Yeah. And you can check that that works. 3 times 26 plus 6 is going to give me 90. What about for x? Does anybody... 28, I mean. 6 times 3 is not 24. Which is what I was saying. Hear it.
2x, which is 3x plus 6 plus 9x. Is that correct?
What do you guys think?
Yes.
3x plus 6 plus 9x has to equal 90. That's true. If those are perpendicular, all, like, that has to equal 90, this has to equal 90. Yes? So I agree with that. But you do have to do 2 problems in this one to find both x and y. remember that that's just going to be 12x plus 6 equals 90. So 12x equals 84. Is that right? Was that does 12 go into 84? 12 times 6 is 60. That's a no 72. I mean, so it's 7. Anyway, I know what I'm doing.
Okay.
12 times 5 is 60. That's my baseline. So then I was just adding 12 without getting a calculator.
That's why I was concerned with calculators. I need to get a calculator to grab it. Just like take
I-
something off.
I use a calculator too sometimes. I just was trying.
Just
That's
like
how I
the
do it.
beside your printer.
She does like
Like,
3 or 4
where's your
months, just so she
microphone?
doesn't-
It doesn't work very. This is the one that works, so it's broken. It's very sad and broken. So it's just laying here, but it still records. Okay. This last thing. Oh wait, it's alright. We closed it. We're not gonna do it. We're moving.
Okay, thank you.
This last thing, I just want to talk to you, and I kind of talked about this earlier in the week about don't trust the picture in your book. I wrote this from your book. I should have credited the book, so I'm not plagiarizing. But the book says, in geometry, figures are sketches used to depict a situation. They are not drawn to reflect total accuracy. There are certain relationships you can assume to be true, but others you can't. And so there's just this lovely thing that tells you what's okay to say. If you had a picture like this, definitely we could say these are on the same plane based on the picture. We can look at them and see that they're on the same line. You can see where things intersect. You could even see that since this makes a straight line, that you could come up with some linear pairs. I'm not going to go through all of these. But there's certain things you're allowed to say. You can never look at a picture and tell me that certain angles are congruent to each other. You can never tell me that certain angles add up to 90 degrees unless the picture tells you that, like with the little box, or unless they tell you in the directions, right? You cannot assume these things if it's not stated there. And so that's what I was kind of emphasizing earlier in the week of, like, don't trust the picture. If it doesn't say this, you can't say it's true. Yes, it kind of looks like, not really, it doesn't really look that. HM is perpendicular to HL. What? Oh yeah, okay. If we extended the line, they're saying HM, it kind of looks like that those make a right angle there. Kind of looks like is never an okay thing to say in geometry. Well, it kind of looks like, right? So I just wanted to emphasize this because I already have been emphasizing it, and I'll continue to emphasize it. Summarizing this whole slide, don't trust the picture just based on how it looks. Okay, so there's actually some questions on your homework, like the last example here, that says, can you say this is true? And sometimes the answer is yes, and sometimes the answer is no. So this is my last example here, to just practice of what are we allowed to say is true. So I put 3 of them here, and I'm gonna be quiet for like 2 minutes. I want you to say, based on this picture, number 1, number 2, and number 3, can you say that that is true based on the picture? Or could you say we don't know enough to determine that? So you could say yes or no based on it. So just think for a minute and kind of jot down yes or no what you think, and then we'll talk about it so we can just make sure we're on the right page here. I don't want to scare you too much by saying you have to not trust the picture. You also have to use what we know, right? So, number 1, angle TYW, I'm going to actually just mark it out. Angle TYW and angle TYU, TYU, that would be right here, yes? Are supplementary. What do you think? You think we can say yes, or you think we can say no? Because why? Yeah, they make a linear pair, which is a straight line, and we had that little thing earlier that said if it makes a linear pair, it is supplementary. We can say that definitely made a line. Those are collinear, so that means yes, we have enough information to say that is true. So now what about for number 2? Angle, I'm going to change colors here. Angle VYT equals 90. What do you think, Eric?
I think it does, because two angles that are adjacent to it are also 90 degrees.
Yeah, it's not marked with a little box, but because this one is marked with a little box, and this is going through it, does that make sense that we know if this is 90, that this is 90? Again, it kind of goes back to that whole linear pair. They add up to be 180. They make a straight line. So we're not assuming things here. We're using what's marked, and we're using our vocabulary to help us. What about this one? VYW. VYW. And TYS are adjacent angles. Garrett? That's just not true, right? It's not even that we would assume it's true. They don't share a side, right? All right, so there's some questions like that on your homework. It says explain the things I was saying. I didn't write it out, but how would I explain it supplementary? Because they make a straight line. Because they are a linear pair. Like Eric said, because the adjacent angle to it is 90 degrees, and maybe because it is a linear pair with that. Stuff like that. You don't have to write a paragraph, but that's what it means by explaining. No, because they don't share a side. That would be an explanation. So you don't even have to write complete sentences, but that's what it means by explain on that problem. So this is homework 1-5. There's a lot of like solving for stuff based on whether they're complementary, supplementary, adjacent, vertical. I think 35 through 39 are all like yes or no, like we just did, and then 49 or 50 are a little bit more challenging problems. I know it's Friday, and we don't like homework on Friday, but there's going to be a homework quiz on Monday, so just make sure that you do your homework so that you're prepared for homework quiz on Monday. And if you can get your thing put back, if the bell rings before you put it back, just set it nicely somewhere